and they knew if management had read the contract, if they went in and saw a bowl of M&Ms. This is amazing for guys that were always drunk to think that clearly about contracts. I mean, it's pretty amazing. So anyway, what we're going to do is we're going to test using this pseudo-random sample of M&Ms that I brought with me today. We're going to test the hypotheses. Here's the hypothesis thrown down by Mars, and I have no reason to doubt it, but I still want to test it. Here's the hypothesis. We should have 10% orange. We should have 20% yellow. We should have 30% brown. We should have 10% green. We should have 20% red, and whatever's left, hopefully it's 10%. Blue. No, blue, yes, hopefully that's 10%. Those are the percentages I've gotten most recently from M&Ms. I have one other set of percentages that I have my spreadsheet test as well, that's sometimes given to me by Mars. I get these formulas back. You'll see. I'll bring it to class next time. If you've been to my office, you've seen them. They're tacked outside my office. They keep falling off. There's so many of them now. But they give me some. Does that sum to 100%, friends? Yeah. It does. Good. So that's 100% of the colors. So you see how it's not a uniform distribution. You've got more browns. You've got slightly less yellows and reds, and the rest are 10% orange, green, and blue. I have another distribution they've given me where I think all of them are slightly different, like 14%, 13%, 16%, 20%. It's a little more annoying. And I have Excel tested for us while we're doing it. So the question now is, if that's not true, what's going to be H1? What's going to be the research hypothesis? Say that again? And one of them's going to be off. At least one of them, right? Can I put the word at least in there if it's okay? At least one of them's off. It might be that one's off and other 5 are good. It might be that 2 are off and 4 are okay. It might be they're all wrong. I mean, there are 64 possible ways to either agree or disagree with those percentages. And here's why I say 64. Either the percentage of orange is 10% or it isn't. Either yellow is 20 or isn't. Either brown is 30 or isn't. That's binary, right? And there's 6 of them, so that's 2 to the 6th power. That's 64. One of those 64 outcomes is all 6 are what they say they are. The other 63, it means at least one is off. It might mean that one's off and these 5 are on. This one's off and those 5 are on. This one's off. Getting back to your question, that's why we don't list the alternative hypotheses out. There are 63. I mean, it's not as bad as this, where it was 1,023. But there are 63 ways to list them out. Or we just say, there we go. At least 1% is off. And that takes care of the rest of them. Remember that beautiful phrase, at least, from 243? Either it is this, or at least one of those is off. And that's beautiful. It sums up the entire thing. It also creates a problem that we haven't addressed, and I believe, Jamie, it's tied to what you asked, or somebody over here asked. And we'll get to it here. We didn't have to worry about it over here with the iPod experiment. Because we could have been wrong over here, right? We could have been wrong with type 2 error. I'm predicting the potential of a type 1 error on this experiment only because I've done this for so many years. And as loud as I am and as many letters as I write to the company, they haven't Andy Dufresne'd me yet. And we'll talk about what that means in a second if you haven't seen Shawshank Redemption. So, what I'm going to do, I'm going to give you all a bag of M&Ms. I think I have enough for everybody in here, I'm pretty sure. If not, we'll have to share a little bit. Crack them open, count how many of each color you got, and then we're going to pull all the results at the end and see what our grand sample is. Does that make sense? That way we guarantee we have enough. Remember, the requirement is we have to have at least 5 expected color. And if I use one person's one bag, we might run the risk of not having that. Because here's why. There's about 40 candies in the bag-ish, 40. If you apply those percentages to 40, you've got 4, 8, 12. You see what I'm getting at? You don't have enough expected orange, green, or blue. But if I put you all together, we guarantee to have enough. Beth, go ahead.
Would it, like on the test, is there...
Oh, I give them to you, yes.
Yeah, no, is there other acceptable ways that we could say the research hypothesis?
Oh, yes.
At least 1%.
Absolutely, Beth. And on the exam in class next week, whatever it is, week after, I don't even require that you write them because I want you to write it in whatever way it makes you feel comfortable. You might write it in words like we did over here. The iPod's random enough. The iPod is not. You could say it in words. The M&Ms percentages are what Mars says they are, right? Mars is the company that, here, I'll give them a little TM in case they're watching. Mars TM says they are.
That's what I was getting.
Yeah, and you can see, I mean, I don't require it on the last exam because I want you to write it in whatever way is comfortable to you.
Right.
And for something like this, you don't have to enter them anyway. The way I write the program, it automatically sucks them all up and then tests the data the one way it knows to do it.
Okay.
Is that cool?
Yeah.
Billy, go ahead.
Are we still gonna practice next week of
Yes.
figuring out
Yes.
which is which?
Yes, that's the week from today. Five tests. Yes, I know, it seems like an awful lot. And we're gonna do them all next week. Thursday, this time next week, what's what we'll do?
Which one's gonna be a lot then?
Whatever was from the last test to this one.
Okay.
I don't remember exactly. So wherever the last test left off, pick up there. Oh, come on now. Cool, I'm gonna pause this so as to not let it overheat.